Hi, and welcome to this short course, Knowledge Graphs for RAG, built in partnership with Neo4j. I'm here with the instructor, Andreas Kollegg, a developer evangelist for generative AI at Neo4j. Welcome, Andreas.
Thanks, Andrew. I'm excited to be here today and can't wait to show you how to use knowledge graphs to improve your retrieval augmented generation applications.
Knowledge graphs are a very powerful, but also one of the more underrated tools of AI. So I hope you enjoy learning about them in this course. Knowledge graphs provide a way to store and organize data that emphasizes the relationships between things. In contrast to traditional relational databases, which organize data into tables with rows and columns, knowledge graphs instead use a graph-based structure with nodes that represent things or entities like people or companies, and edges that represent the connections or relationships between these entities, such as an employer-employee relationship. So when you hear nodes, think of things or entities, and when you hear edges, think of the relationships between the things. Each of these nodes or edges in the graph can also store additional information about the entity in the case of the node or the relationship in the case of the edge. For example, a person node could store an individual's name, email, and other details. A company node could store data like the number of employees, annual revenue, and so on. And the employer-employee relationship between the company and the person would be represented by an edge between these two nodes, and the edge could also store additional information about that employment relationship, like the person's job title, start date, and so on. The graph structure of nodes and relationships is very flexible and lets you more conveniently model some parts of the world than relational databases.
That's right, Andrew. Knowledge graphs make it much easier to represent and search deep relationships, since the relationship itself is a component of the database, not just a key shared between two tables. This enables much faster execution of queries, getting you to the data you need more efficiently. This is why web search engines and e-commerce sites that offer product search capability have found knowledge graphs a key technology for delivering relevant results. In fact, if you search for, say, a celebrity on Google or Bing, the results you get back in the cards to the side are retrieved using a knowledge graph. And when you combine a knowledge graph with an embedding model, you have a very powerful tool for carrying out retrieval augmented generation with an LLM. That's because you can take advantage of the relationships and the metadata stored in the graph to improve the relevance of the text you retrieve and pass to the language model.
In a basic retrieval augmented generation or RAG system, the documents you want to query or chat with might be first split into smaller sections or chunks, which are then transformed into vectors using an embedding model. Once in this vector form, you can use a similarity function like cosine similarity to search through the chunks of text to find the ones relevant to your prompt. But it turns out that storing these text chunks in a knowledge graph opens up new ways to retrieve relevant data from your documents. Rather than just similarity search using text embeddings, you can retrieve one chunk, then traverse the graph to find other relevant chunks of text, which gives your LLM more complete context. You see in this course how this can reveal connections between text sources that similarity-based RAG can miss.
In this course, you'll learn how to build a knowledge graph to represent a collection of financial forms that companies are required to file with the Securities and Exchange Commission, a U.S. government agency that regulates and oversees markets and protects investors. You'll start with an introduction to knowledge graphs and see how you can use Neo4j's query language, called Cypher, to explore and modify a fun graph of movie data. Then you'll see how you can use Neo4j in combination with a text embedding model to create vector representations of text fields within the knowledge graph. Next, you'll build a knowledge graph to represent one set of SEC forms and use LangChain to carry out RAG by retrieving text from this graph. Lastly, you'll go through the graph creation process one more time for a second set of SEC forms, connect the two graphs using some linking data, and see how you can use more complex graph queries to carry out retrieval across multiple sets of documents. All this together allows you to ask some really interesting questions of the SEC dataset.
Thanks, Andreas. This sounds like a really exciting and timely course. Many people have helped with the development of this course. On the Neo4j side, Zachary Blumenfeld, and from deeplearning.ai, Tommy Nelson, and Jeff Lodwick all contributed to this course.
It's really an exciting time to learn knowledge graphs, and I'm so excited to see what you are going to build using knowledge graphs. This course covers a lot, but you'll walk through everything step by step so that you'll understand in detail how to build knowledge graph systems yourself.
After finishing this course, I hope you'll be able to use knowledge graphs to help your systems better understand relationships between data and maybe even make some discoveries in your data that are really notable.